Hello, welcome back to Blender Sushi Live Loading. In this episode, we're gonna try to explore the Voronoi 3D once again using Sverchok, but we're gonna use it to kind of simulate cell splitting. It's not like a really like a realistic cell splitting, but I think this is still kind of interesting technique, and I want to share it with you. So let's get started. Compositing Sverchok Add-On, new, and right away we're gonna start with an object. I'll use a box for starter. So box and viewer draw, you're gonna get a box and you can scale it. Maybe I'll scale it 3 for now. I'm gonna save it as cell splitting Voronoi. And I will use the script node live, and the Voronoi 3D is inside this guy. Just select the Voronoi 3D and you get a Voronoi node. So we need to generate like some random points. Basically, you can use for random scattered points, you can use the vector P, which is like a 3D matrix grid, or you can also use like a random vector. You probably used both many times already. So with this guy, so this is the original objects, and I'm gonna just use the edge for now. Actually, I'm gonna use the maybe I can use the wireframe. So this is the wireframe mode, and as you already know, this is like that's random points. We're gonna try just use a bunch of points, and this is a vector P field. Let's see. Okay, so that's vector P field. Make it 2 by 2 by 2, and you get a supposed to be okay 8. So let's try with a vector P field for now instead of random vector. They're kind of similar if I kind of randomize these points anyway. So I'm gonna use these points, plug into this Voronoi, and then plug this guy in there, and let's check out the result. We get these objects, kind of like a splitting of objects. Let's turn on shading. So you can see it's already doing this Voronoi thing, except that it's not randomized. It's very much like a kind of like a grid, which is actually pretty cool. But once you turn on the randomization, you start to see the kind of Voronoi pattern. What's interesting with this guy is the shrink. You can go from 1 to 0, and you can actually do the opposite, like all the way until you actually get the original objects. So that's the whole idea right there. Currently we have 4 divisions of these objects, like 4 Voronoi. Actually, how many of 2 by 2 by 2? Okay, 8 Voronoi pieces. It's a 3D pieces. We can bake it out, and if we bake up, this is like only single objects. But if you like doing like a separate loose part in Sverchok, you will see if I bake it, we actually have 8 different pieces of objects. Okay, let's check. There's actually another node. Okay, this one, that's interesting. Well, anyway, with these 8 pieces, we can actually transform them individually. So if I use the matrix into this guy, and I use the original vector points, you will see that if we use vector math and multiply scalar, we can actually kind of push the objects outward. And you will see real quick, after I push it out, and if I increase the shrink all the way, this guy is going to become the original object, which is just the cube. And that's how we're going to do the splitting, like the cell splitting. Let me try to demonstrate the same thing, but instead of using the box, I'm going to use another object. I use shift and then drag. I get this what do you call it, the rerouting. So now instead of using box, I'm gonna use a cylinder. Let's try cylinder, polygon cylinder. So we have 8 cylinders. Let's reduce the number. If I kind of see, this is not, of course, not like a polygon splitting, but if I kind of reduce the shrink and this become like a Voronoi pieces, and there you go, it's become a single part. So if I zero this out and then make this 1, we get the cylinder being broken into Voronoi pieces. By the way, with the points, since Sverchok doesn't have scatter points inside the mesh yet, so you kind of need to ensure that this 8 points should be like inside the bounding box of the object. So you always keep that in mind. In this case, it's kind of doing it because the 8 point is pretty much like inside this cylinder. Maybe in another case it will not work. So to make this simpler, I will use just an icosphere. You know, icosphere is just like, it's looking like a ball, and let's get rid of the points and this guy. So now we have pretty much 8 pieces of this icosphere. I can make it smaller, like 2 by 2, so we get 4 slices. Remove the randomization. So now we have this 4 pieces. So we can push the 4 pieces out, and then we can animate the shrink vector, and we get a new icosphere. So that's kind of like a cell splitting that I was thinking about. We can, of course, increase the number as we need it and push it out more. But see, the effect is quite neat, I think. And the shrink currently, the limitation, what's the limitation of this? There's no limitation. It's just like by design, the shrink actually like a single value that controls every pieces. So it's not like vectorized here, but you probably can use the monad thing in Sverchok in order to get the vectorization. But you can feel free to go inside the script node and then maybe make your own changes and tell the Sverchok developer that you actually add some changes. This is the script. It's a Python script. It's written by a Sverchok developer to generate this Voronoi pieces stuff. So once again, you can randomize it. If you randomize it, you get something that's more like a Voronoi pattern, like that. But I kind of like this kind of it's not like a Lego pieces. It's more like it's not like origami. It's just a fracture, you know, fracture of objects. It's nothing too complicated. It's become so simple. But what I like is the interactivity and how we can kind of play around with this idea. So you break the pieces. You break the geometry into pieces, and then you can basically grow it. So it's become like a kind of like cell splitting, sort of. Yeah, sometimes you need to go very high with this number. There we go. So that's the cell splitting animations. So vector p field will work. Random vector actually will work as well. Simpler, I guess. So let's try like 3 random vector. So the scalar here will push the objects outward, and this control the number, randomize the seed if you like, scale, not too high. If too high, then the point's gonna go out from the boundary, and this is the string. Okay, this should be 1. Yeah, so that's the idea anyway. You split it, and then you push it out, and then you grow it. It's become a new cell, and you can actually combine the scale of this. What I mean is maybe use this a floating number here and there. So as you kind of push it out, it's gonna grow out. This should be plugged into the shrink factor as well. So so you get this kind of animation, automatic. So you start like this, and then it's gonna be pushed, and then it's gonna grow, kind of like a driver. It's pretty cool. Not perfect, but can be modified. That's just an idea. And this should work with any kind of geometry. So we try box, cylinder, icosphere. Let's try Suzanne. Suzanne is actually made up of multiple pieces. With Suzanne, it's a good idea to just remesh it, smooth it. Yeah, something like this, a single piece of Suzanne. Remove disconnected pieces, yes. And objects in, get Suzanne, post modifier on, because we use the remesh, and just plug in this data, and hopefully we have Suzanne. So Suzanne being split into pieces, and then it grows into new Suzanne. So we have 4 Suzanne. Let's try again in a little bit slower. So we start, let's see, I think this shrink should be 1, okay. Shrink shouldn't be 0, I think we need to use math here. +1, x +1, this goes in there, and this goes in there. So now we can push this guy. So we have that kind of effects. Well, actually, it works better like this somehow. So Suzanne got pushed, Suzanne splits, and Suzanne becomes multiple Suzanne. Maybe have more. Okay, 20. I have not tried this with metaballs yet, but I think metaballs will also work. So if you don't want to split too fast, maybe use a multiplier over here. Just multiply it by a certain factor. So it's gonna be pushed a little bit slower. You got the idea. There you go. Suzanne cell splitting. Okay, hopefully you find this useful. Let me know what you think. Let's try with block as well. Actually, with no smoothing, less. Okay, this should be pretty good. So that's the original object. So we start from 0, and this gonna give error. It's gonna split and should be pushed already. And it's gonna grow and become new Suzanne. That's kind of too fast over there. Yeah, but I think you got the idea. But so yeah, that's pretty much it for this live noding. Let me know what you think, and if you have any feedback, suggestion, let me know, and I'll see you in the next video. Thank you. Bye.